my math class. I am your teacher once again, Teacher Ray. And today I am going to discuss Lesson 7.1, Understanding Likelihood and Probability. And this is in your textbook, pages 355, 360. Oops! Don't forget, you must have your textbook, copybook, and pen. But before we start our lesson for today, let's have your answer for your homework last week. Here they are.
Let's start with your textbook 475 item 7. Find the volume of the prism. Take note that the base is 4.2, the height is 2.8. So we have 41.16 cubic meters as the volume of the prism. Next is item 14 in your textbook page 476. A glass bead has the shape of a prism with a rectangular prism removed. What is the volume of the glass that forms a bead? To solve for this, we need to find for the volume of the larger prism. Using the formula, volume is equal to the area of the base times the height. The side lengths of the base are 3 and 3, times the height of the prism, which is 5. Multiplying them together, it gives a product of 45 cubic centimeters, and this is now the volume of the larger prism. Now let's find for the volume of the prism removed. Using the same formula, volume is equal to the area of the base times the height. The area of the base is 2 and 2 times the height of the prism, which is 5. It gives a product of 20 cubic centimeters. This is now the volume of the prism removed. Now to find for the volume of the glass that forms a bead, we need to subtract the volume of the larger prism and the volume of the prism removed. The volume of the larger prism is 45 cubic centimeters, and the volume of the prism removed is 20 cubic centimeters. It gives a difference of 25 cubic centimeters, and this is now the volume of the glass that forms a bead. Here are the objectives of the lesson. Use probability to describe the likelihood that an event will occur. Relate probability to mathematical fairness.
What is probability, and how is it related to outcomes? Think about this question during the lesson. Alyssa and Sherry spin the pointer on the spinner and record the color that it lands on. The table shows their results after 100 spins. How can Alyssa and Sherry explain their results? There are 4 possible results, or outcomes, when Alyssa and Sherry spin the pointer. The 4 outcomes are the pointer lands on the red section, the yellow section, the green section, and the blue section. Are each of the 4 outcomes equally likely?
Select your answer.
Each section of the spinner is the same size, and there is 1 section of each color. So, each of the 4 outcomes is equally likely, because the pointer has an equal chance of landing on any of the 4 sections. This time it happened to land on the green section. Each time they spin the pointer, the likelihood, or probability, of the pointer landing on red, yellow, green, or blue is the same. Each of the equal-sized sections is shaded 1 of 4 colors, so the probability of the pointer landing on any given color is 1 out of 4, or 1/4. What is the probability of the pointer landing on each color, expressed as a percent? Since 1/4 equals 25%, the probability can also be written as 25%. the pointer should land on each color about 1 out of 4 times, or about 25 times out of 100 spins. Alyssa and Sherry's results are close to the expected results.
Different spinners will have different probabilities. Drag the slider to see how each spinner affects the probability.
Now you know how to use probability to predict how often an outcome will occur.
How might the probability of the pointer landing on a given color change for the spinner shown at the right?
Probability will not change. There are still an equal number of sections shaded each color, and the sections are all the same size. So, the probability landing on any given color is 2 out of 8, or 1 out of 4, or 1/4, or 25%.
Carrie will roll a number cube with sides labeled 1 to 6. Part A. What is the probability that she will roll a 2?
Only 1 out of 6 total side is 2. So, the probability is 1 out of 6, or 1 over 6.
Part B. What is the probability that she will roll a number less than 7?
All 6 numbers on the cube are less than 7. So it is certain that she will roll a number less than 7. The probability is 6 out of 6, or 1.
Part C. What is the probability that she will roll a number greater than 6?
None of the 6 numbers on the cube are greater than 6. So it is impossible to roll a number greater than 6. The probability is 0 out of 6, or 0.
Game piece shown has 12 sides, labeled 1 to 12.
Part A. What is the probability of rolling an 11? It's 1 out of 12, or 1 over 12. Part B. What is the probability of rolling a number greater than 5? It's 7 out of 12, or 7 over 12. Part C. What is the probability of rolling a number greater than 12? It's 0 out of 12, or we can say impossible. Now let's do example 3.
Marisol designed a spinner for a game. The spinner is fair if there is an equal chance for the pointer to land on each letter. Is the spinner a fair spinner?
If we select section C, the probability of the pointer landing on C is 1 out of 6, or 1 over 6. If we select section D, the probability of the pointer landing on D is 1 out of 6, or 1 over 6. If we select section B, the probability of the pointer landing on B is 1 out of 6, or 1 over 6. If we select section E, the probability of the pointer landing on E is 1 out of 6, or 1 over 6. But if we select section A, the probability of the pointer landing on A is 2 out of 6, which is equivalent to 1 out of 3 or 1/3. It is more likely that the pointer will land on A than on any other letter. So, it is not a fair spinner. Let's try it. Is the spinner shown a fair spinner? If yes, explain why. If not, describe a change that could make the spinner fair. The spinner is not fair. The sections are all the same size, but 5 sections are blue, 4 sections are red, and 1 section is gray. The spinner will be fair if the gray section is shaded red, because the probability of the spinner landing on either blue or red will be 5/10 or 1/2. And now we are done with the first part of our lesson. See you in the second part.